Hello Chem 1A, this is chapter 12, lecture video 1, and we're going to be discussing in this chapter liquids and solids, particularly their properties, kind of like we did in chapter 7 with gases. So let's get into this. The first thing we need to talk about before we talk about liquids is the difference between what is known as intramolecular and intermolecular forces. Now, intramolecular forces we've actually been learning quite a bit about in the last couple chapters. This is bonds. So intra means within, and forces and molecular, right? So what are the things holding the molecule together? These are intramolecular forces. These affect stability, like with our bond order. There are different types of intramolecular forces, like ionic bonds or covalent bonds. Whole bunch of stuff there. We've spent a huge amount of time covering it. We just didn't call it intramolecular forces, but that's what it's called. For this chapter, we're going to focus on the other type of force that our molecules experience, which are known as intermolecular forces. And this is attractions between particles, right? So if I have two molecules near each other, those two molecules all bonded together inside of each other could also attract to one another. For instance, if I have two water molecules next to each other, those two water molecules are actually going to attract to each other a little bit and have a force holding them slightly together. These forces are known as intermolecular forces, and the prefix inter means outside of, so hence intermolecular forces, forces outside of the molecule. These affect bulk properties of our liquids like vapor pressure, boiling point, viscosity. There's a bunch. We're going to talk about the intermolecular forces first, and then we'll get into how these intermolecular forces affect properties like boiling point and so on for our liquids. So what are intermolecular forces? Well, they are the forces that hold both solids and liquids together, and typically they're attractions and repulsions between molecules. They are not chemical bonds, and this is a big distinction, right? Intramolecular forces are chemical bonds. Intermolecular forces are attractions between molecules. They are, in fact, much, much, much weaker than a chemical bond, as we'll talk about on the next slide. So what are the effects of an intermolecular force, or what affect an intermolecular force? One is charge. If we have an ion versus a neutral molecule, we'll probably have different possible intermolecular forces. The polarity is a big deal here. So going back and reviewing your chapter 10 material on how to determine whether a molecule is polar is going to be important for this chapter. So if a molecule is polar or nonpolar, that'll definitely affect the types of intermolecular forces that are present in that molecule. And finally, molar mass actually affects only one of our intermolecular forces, particularly its strength. And we'll get to that in the next lecture video. It doesn't actually have any effect on what types of intermolecular forces are present, more just the strength of one particular type of intermolecular force. Okay, so let's just talk a little bit about how intermolecular forces are so much weaker than a full-on chemical bond. So if we look here between these two HCl molecules, we have a covalent bond right here holding the H and the Cl together, also right there. And if we look at the bond strength of that HCl bond, we have a bond enthalpy of about 432 kilojoules per mole. That's a relatively reasonable covalent bond enthalpy. If we look at the actual strength of this intermolecular force holding these two molecules together, it's only at about 20 to 30 kilojoules of energy. So you can see we're talking about a difference of almost 20 times in strength, right? Our bond strength between the HCl is almost 20 times stronger than the intermolecular force holding these two molecules together. Now, And this molecule is actually, this intermolecular force is actually our middle strength intermolecular force. So it's not the weakest one either. So you can kind of get a feel for this. This is why chemical bonds are so much more strong than our intermolecular forces. Intermolecular forces are a lot easier to break because of this. All right, so if you have any questions at all, please don't hesitate to reach out. I'm always happy to set up individual Zoom meetings, or you can always come to my office hours. I'm always in Zoom. Happy to help you guys.